All right. (17-2), day 2. Again, here it's not going to make a whole lot of sense because it says remember. Obviously, you don't know what it means yet because I'm jumping all over the place. It says remember that the derivative means a general formula for determining, and what it determines is slope. And what really, that's the easiest answer there is slope, and slope is really a rate of change. Now, if we have a line, slope's very simple. Okay. But what if you don't have a line? Because I think we've all seen plenty of these throughout your high school career so far. And what about right there? Well, what you do is you basically put a tangent line right in there. Remember, tangent means it hits it once. And that's the slope that you can determine if you use the derivative. Okay? And the nice thing is you could even choose that one, and you can find that one as well. One formula will basically tell you all of these. All you have to do is substitute in different information. Okay? And so it is very much a physics, this is where a lot of physics comes from. This basically is change in y over change in x. And that's really all it is. When you get to calculus, you will actually use this. This is called the definition of a derivative right there. We're going to go actually right to the shortcuts so that hopefully we can go through shortcuts a little bit quicker when we get to them. Now, I believe that these three should be very easy to actually figure out the derivative. Now, have you actually done a derivative yet? No, you haven't. But I'm telling you that the derivative tells you slope. Can you agree with me that that first one there is basically y equals x? Isn't that a slope? Isn't that a line? But what is the slope of that? 1, right? It's right here. So guess what? The derivative, which you can notate a lot of different ways. One way is f prime of x is one way you can denote derivative. Flat out equals 1. Because does it matter where I choose on that line? The slope can be 1 no matter where I go, isn't it? Because let's face it, that pretty much is that line right there. If I choose that point, what's the slope? 1. This one over here? 1. That one there? 1. Doesn't matter. So the derivative for this one, and here's another way to write it, is y prime. Well, what's the derivative of that one? 3, because that, again, is a line. What's the slope? 3. So y-intercepts up 3 over 1. So something like this is what that would look like if you graphed it. Am I going to ask you to graph them all? No. But I'm showing you, again, if I choose that point right there, what's the slope? 3. That one there? 3. This one there? 3. Doesn't matter. And so how about letter C? How could we do that? Well, y prime is how you would take basically the derivative of the left side. Now you have to take the derivative of the right side then, 100, because they're all lines. Again, if they're lines, very simple, as long as you know what derivative means. We're actually going to come back to these, and I'm going to show you that the shortcut we use on the harder ones also technically still works here. Okay? So, the next one on there, is that a line? What would it be? Parabola that happens to open up, right? Well, this particular shortcut I'm going to show you will work if it's just basically terms added together. Are any of these terms multiplied by each other? No, it's just 3x squared plus x minus 1, but not a line. Right? I probably should have an f of x out front or something like that, or a y, but you can add that in there if you want. So you take the derivative of the left side, well, that's just f prime of x. That's no big deal. Normally the left side's really easy to take the derivative of, you just change the notation. So here is your first shortcut. What you do, whenever there's a power, and I agree there's a power here, which is 2, correct? It also has this number out front. What's that number out front called? Starts with a C. Coefficient. What you do is you take the exponent times the coefficient. So you take 2 times 3 is 6, write down the variable, which is x, and then you take your old exponent down 1. So basically you subtract 1 from it. Do you agree the exponent on that term was 2? If you take it down, it's down to 1. Now here's where it gets a little tricky. This is basically a 1x to the first, right? That's what would be there. So what do? You take the exponent times the coefficient, so that is 1. But then it's x to the 0. Wow. Well, we'll come back to that x to the 0. But do you agree we followed the same pattern for that one? Now right here, it would really be x to the 0. Do you agree with that? If you had to write an x up there. And so then you take 0 times negative 1 and you get 0. So then does anything matter after that? No. And so basically what's really nice about derivatives is constants like that just go away. When you take the derivative, gone. And didn't that happen earlier when we had some constants up there when we did the lines? The constants, gone. Now somebody mentioned something about that right there, x to the 0. Anything to the 0 power is 1. So this is really saying 1 times 1, isn't it? So the cleaned up version of this derivative is 6x plus 1. Now you might be wondering, well, how does that work like the lines do? Well, I think you told me already that this would pretty much be a parabola that opens up, correct? Something similar to that? What you have to do is, do you agree if I change what point I'm asking you for, the x value changes, correct? Like over here is going to be a different x value than that one, right? What you do is you put that x value in there, it'll tell you the slope of that line. Whichever x value you want to know at, it'll tell you the slope. It's a nice general little formula for you. Okay? And you can ask any point you want that's actually on that graph, and it'll tell you. So do you think the shortcut will work for that next one? Am I multiplying any of the terms together? No, we're just adding them and subtracting them. So can we use the same setup? Yeah. Now let's pretend this is y equals. So the derivative of this side is y prime. What should be the derivative of 7x to the third? 21x squared. How about negative 2x to the second? Are you sure? Do you take the negative with it? Yeah, it's a negative 2 out there, yeah. And times 2 is a negative 4. Really x to the first. So do you have to write the 1? No. Is it okay if you do? Sure. And what did we just learn about constants? And why is it gone again? Because if you had to write something, it'd really be x to the, and then 0 times anything, gone. And so you don't have to worry about it. Is there any cleaning up that we need to do? No. And now remember, this is cubic, so it probably looks something like that, right? Again, these x values are all different, and I can ask you for any of them. All you do is you put x in there, you put the same value in there, you do the math, and it's going to tell you the slope. Or maybe it'll tell you this one. Or maybe it'll tell you that one. It all depends on which one you are asked for. Okay? Is that a question or just a, okay? Okay. How about C? Am I multiplying terms together on letter C? No, it's just x to the 1/4 power. What does 1/4 power mean again? Just out of curiosity. Right? X to the 1/4 means the 4th root of x to the first. You're going to learn that this part of chapter 5 from Algebra 2 is going to prove very important because we're not really going to want to look at things like that when we're in calculus. We're going to want to look at them like that. You know why we want to look at them as x to the 1/4? Because that shortcut I just showed you still works. Are the numbers as nice? No, but it still works. So let's see if you can remember that shortcut. What's the coefficient on letter C?
1.
A 1. Now what are you supposed to do? You're supposed to take the coefficient times the exponent. And what is the exponent here? It's 1/4. Times 1 is 1/4. X. Now here's the hard part. You're supposed to go down by how much? 1. So if you're at 1/4, how do you take away 1? Right, it would be, because if you have 1/4 and you subtract 1, we're going to use 4/4 as our option, right? Do you agree that would be negative 3/4? Now here's where you're going to actually kind of like what I have to say for a lot of calculus is the x, I hope you agree, is unhappy right now because it has a negative exponent. Again, chapter 5 from Algebra 2. Right? This 1 and the 4 that are already there, the 1/4, those are fine, right? So the 1 wants to be on top, the 4 wants to be on bottom. Where does x want to be? Right now, x is technically on the top. Wants to be on the bottom. Okay, and if you rewrite it, okay, right, because it'd be x to the positive 3/4 once you put it down there. Now, in all your other classes, what were you told about radicals?
Can't be on the bottom.
Can't be on the bottom. But in calculus, we actually don't mind. Is it simplified based on all those rules you've been told before? No, it's not. But to do what you've been told all those times before makes the problems harder. And so I strongly recommend you leave them like that. I would caution you of leaving it like this because we are going to set this equal to something. And it's going to be easier to work with like this than in that form because the negative gets a little confusing when you set it equal to something. So how about this one here? What's the coefficient? 1. And let's pretend it's y equals again. So we'll do y prime equals. What should be the first thing I write down? 7/3. Yeah, take 7/3 times 1, so 7/3. Followed by an x. I've been told 4/3.
4/3, yeah.
Positive or negative?
Positive.
Why positive?
Because it's 3/3.
Right, you would take 7/3 minus 3/3 is just 4/. Is this x unhappy with where it's at? No, this one's fine. You could leave it that way, or what some people like to do is they do like to kind of clean things up. And then up here, where does the 3 go? Where does the 4 go? So technically, we could clean that one up a little bit. We're not going to at this time because, again, we're going to be setting this equal to something as you get through calculus a little bit more. And so you're going to want to see it more like this. Okay?
So does it matter?
Well, if you're looking at the one above, the 7/3 x to the 4/3, I would probably suggest not leaving it that way because of what we will be doing later. So I would say it's not technically wrong, but it's going to be something you might as well just get used to rewriting it this way because that's what you're going to have to do at some point. So might as well get good practice.
At some point, is it here? It says to be a lot, which means obviously.
So what do you notice about E? Yeah, there's multiplying. This shortcut does not work if you're multiplying terms. But there's something very easy we can do. Just distribute. Once we distribute, our terms multiply together anymore. No, so we can just do that. So what I would do is say, take care of this. So you take 4x times x squared, and it's basically 4 times 1 is x to the 3rd, very good, and then take 4x times 1 is plus 4x. Now here's the question, have I taken the derivative yet? No, and that's why the notation's so helpful. Because if you write y equals there, then you know you haven't taken the derivative yet because it's not y prime. So now I'm going to go ahead, is there any multiplying now? No. Now it's sitting there perfect. And so you say, all right, let's take the derivative, and you can just take them separately. And so what's the derivative of 4x to the 3rd? Squared and plus 4. Very good, because it is 4x to the 1st. And so remember, it would be x to the 0 once you did it, so it kind of goes away. Any questions on why it's just 4? Or why it's 12x squared for that matter? Because we took the 3 times the 4 and then took it down a power. Okay. So you might notice f is very similar with one small difference. There's a plus sign there. So you can't distribute, but you don't have to. Yeah, am I multiplying anything times something else? No, I just threw the parentheses in there to make it look like E, put the plus sign there to see if you would try and distribute there. Because really, couldn't you just rewrite this as x squared plus 4x plus 1? Isn't that the same thing? And what would that be called? What kind of order is that when they go down? What's that called? Descending order. Very good. So have I taken the derivative? How do you know? Yeah, it's just y. It's not y prime. And so you go ahead. Now, sometimes people struggle with x squared. Yeah, it's just 2x. I don't know why that one is the one that people struggle with, but it is. 4x, the derivative is? Yep, just a 4. The derivative of 1 is again gone because it's timesing by 0 really, and so that's the derivative. Okay. Keep in mind that in calculus you will have to do some by the definition to prove to your teacher that you can do it that way.
Wait, so if you said teacher, that's there.
Now, wait a minute. I told you I was going to show you that this still works using that other shortcut. Does it? Well, you were just smart enough to realize these were lines. So this is really x to the first. Can you use that same shortcut? You take 1 times 1, and then so it's y equals 1, x to the 0. Still works. This one here is y equals 3x to the 0 plus nothing, and same thing here. So it still works. But knowing its lines is very helpful because you are looking for that slope. And obviously, as they become having more curves to them, it gets more complicated. Okay, so this one has some negative slopes and some positive slopes. It all depends on what x value is chosen. Any questions? We did.